Hi guys, welcome back to talking a little bit about electron configuration and orbital diagrams. I'm sorry we went so quickly this morning. I know we didn't cover enough and a lot of you were getting super confused, but it's okay. We're going to take as much time as we need. We're all going to get to the point where you can draw these and it's going to be great. So let's kind of review the big ideas that we picked up yesterday. So we said that electrons are present around the nucleus of an atom, and there are a couple of different ways that we define that. The first level is the energy level. That's the outermost shell. And as you kind of were getting by the end of the period, that energy level corresponds to a period or row across the periodic table. So any element in period 1 can place its electrons in energy level 1. Any element that is in period 2 fills the first energy level, and then it has to go to the second energy level to place the electrons. We said that within those energy levels are sublevels. First energy level has only an S, the second has an S but it adds a P, the third has the S and the P and it adds the D, and so on and so forth. An S sublevel always only has one orbital. A P sublevel has 3, a D sublevel has 5, and an F sublevel has 7. So SPDF 1, 3, 5, 7. I'm kind of using this corny analogy of like floors in a hotel room. So if you want to think about the energy level as the floor in the hotel room, the sublevel is the room, and the orbital is how many beds there are, and every bed can ultimately hold 2 people, but they'd prefer to just have one person in a bed to begin with, so we're always going to fill those orbitals just one electron at a time. So let's take a look at the periodic table, and you can be looking as well as at your diagonal trick that you have there, because what I'm going to do is use this orbital diagram here to kind of show you how it corresponds to the periodic table, and then we'll do a couple examples. All right, so unfortunately the first example, family 1, hydrogen, helium, even though we stick helium over here, it kind of should be here, and you'll understand as we get a little bit further into chemistry why helium's over here. It's a noble gas, and we want it in the same family with all those other noble gases. So energy level 1 only has an S sublevel, and it can hold 2 electrons, 1, 2. Helium has 2 electrons. Helium fills up this outermost energy level. It's a noble gas, it's inert, it's non-reactive. It's a little bit of an exception to that octet rule, but you'll see that it works pretty slick the rest of the way through. The next element, lithium. It starts the second energy level. It has just an S sublevel. They can always hold 2 electrons, so the 2s has 1, 2 electrons. Here's my 2s with only 1 orbital. After the 2s, I move to the 2p. First energy level only an S, the second has an S, but it adds the P. The P sublevel has 3 orbitals, and remember we need to draw the line for all 3 of those orbitals at once, because we're going to fill 1 electron in each bed or orbital first and then come back and pair them up. And the up and down arrows just show direction of spin. So notice I have 3 orbitals, 2 electrons each, 6 electrons, 1, 2, 3, 4, 5, 6. Now the 2p is filled. After the 2p, follow on your diagonal, I go to the 3s. After the 3s, I go to the 3p. Now things start to get a little weird. So watch on the periodic table. Here's my 3s. Then I go across to my 3p, looking good. But notice that after 3p, I go to the 4s. Okay, everything's still good. But then I go to what is called the 3d up here. So after the 4s, I go to the next line and I'm into the 3d. And think about it. The D sublevel, that third energy, the D sublevel is first appears in the third energy level. First energy level has only an S, the second has the S and the P, the third has the S and the P and adds the D. So this is actually 3D. That's why I gave you this nice colored periodic table that it's labeled on. It has 5 orbitals, 2 electrons each, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. After the 3D, then I come back to the 4p, and then I go to the 5s. So you can see that by the time we get that that 3D, that first time the D sublevel appears, things start to get just a little wonky. But the minute you can take this and make yourself understand this, and even though your Chem Helper's periodic table doesn't have these labels on it, after you do a bunch of these, you're not going to need that. You know, this is S, this is P, this is D. Remember, we're only going as high as krypton atomic number 36. So let me show you a couple of examples from your worksheet, the one we started today, page 13. Okay, so here is the electron configuration for sodium. There's just boxes here instead of the lines like I was drawing it in class. So we start, here's the deal. I can look and this configuration for sodium, I can see that it's got one electron in the 3A. Well, boom, there's the 3A. It's the first element in. I know that I drew it correctly. I guess unless you kind of mix up these orders. But remember, it's super easy to draw that diagonal on your test paper and just follow along. So sodium is first energy level. It has an S, only one orbital, 1, 2 electrons. Sorry about that. And then after the 1s, I go to the 2s. It fills in its 2 electrons. So this is up to electron number 4 right there. Then I scoot over to the 2p. Remember, I have to draw the 3 lines to show all 3 orbitals because you want to get in the practice of showing them like up-down arrows. Then I go all the way to neon. I filled up my 2p. I don't know why there's not a little arrow there. I just realized that. There should be. I go to the 3s. There's sodium. It has 1 electron in the 3s. And again, I can check that then. So then if I look at the other kind of information I want to know about it, I want to know how many valence electrons it has. Remember, that's all the electrons in the outer shell. So it has some first shell, some second shell. Right now, its second shell is filled. It's got 8 electrons in its second shell, and it's got 1 electron in the outermost shell, which is the third one. 1 electron in its outermost shell. Remember that all atoms want to have 8 electrons in their outer shell, which means they're always going to have this noble gas configuration. 1, 2, 3, 4, 5, 6, 7, 8. And because this always shifts down, its outer shell is always going to be, it's going to gain electrons, like until it gets a noble gas configuration, or it's going to lose them. So what is sodium going to do with 1 valence electron? It's going to lose it, and look what happens. When it loses 1 and only has 10 electrons, now it's got a noble gas configuration. On the opposite side of the spectrum, I think in class today we did sulfur. Sulfur has 1, 2, 3, 4, 5, 6. It has 6 valence electrons. It's going to gain 2 more and take on the noble gas configuration of argon. Since it gained 2 more electrons, it has a -2 charge. So I think we've kind of talked about all of the big ideas for orbital diagrams. The thing you want to remember about the dots around the ion is that it always has to show a noble gas configuration. So I think this is what Emma was trying to ask about in class today. When sodium loses its 1 electron, it now has 8 electrons in its outer shell. It's got neon's noble gas configuration, and it's stable. That's why it's easy for it to lose 1. If sulfur gains 2, it's got a full outer shell. So when I show the dots for the ion, if it gained electrons, if it's going to be a negatively charged ion that has 5 or more in gain, I'm always going to draw it with 8 dots around it. If I say it's a positive ion that has lost electrons, I'm going to draw it with no dots around it, because we now as chemistry students understand that that when sodium lost 1, I draw it with no dots, and its electron configuration looks like neon, and I just write it as Na+1. Let's talk a little bit about the I'm going to mention this because you're going to see a little bit of this on the answer key just so you understand it. I hope you're getting the idea that by the time I'm writing the electron configuration for krypton, if I wrote the electron configuration for all of these atoms in a row, like I just said, here's sodium, here's magnesium, here's aluminum, here's silicon, here's phosphorus, all I'd be doing is repeating everything I had written for the one before it, and I just keep adding one more electron, right? I mean, the electron configuration of phosphorus is silicon's electron configuration, but I'm adding one more into a p sublevel. So it gets kind of redundant sometimes, and it feels sort of like busy work once you've demonstrated that you can master the idea. So what we eventually let you do, but for the quiz or test you have to write the whole thing, we let you do a shorthand abbreviation for the electron configuration. So if I were going to write the electron configuration for sodium, I would say, well, it's neon. It's got that neon core, and then just a 3s1. If I were going to write it for sulfur, I would say that it's neon. I put the little neon in a bracket, and then 3s2 and 3p 1, 2, 3, 4 for sulfur, just so that you understand what that looks like. Now let's take a look at writing, I just put a bunch of those in, the electron configuration. All this electron configuration is, and make sure this makes sense to you, is sort of a shorthand way of representing what I just drew in my orbital diagram. So when we look back at sodium that we were talking about, its electron configuration, here's its orbital diagram. It's showing where the electrons are in specific orbitals. Its electron configuration is that shorthand way of summarizing that. So I would say sodium is 1s2, 2s2, 2p6, 3s1, just like you can see in your slide presentation there. So give it a shot. You are scheduled. Mr. Hulke, remember, has the answer keys to everything, and he knows that he can give you clues if you ask him a question. If you say, does this one end in the 4s sublevel? He can say yes or no. And again, you should be able to look at this and know if you're ending in the right spot. Calcium has to end with 4s2. Aluminum has to end with 3p1. So give it a shot. I think you're going to be okay. Here's what I think we'll do for Friday's quiz. I'm going to let you take it as a group quiz, a partner quiz. And if you like your score and you feel it was good, then you're good to go. Otherwise, we'll go back over all the questions that you have on Monday, and I'll let you take the B version of the quiz for full credit in class. And we can run some test review sessions on Tuesday during lunch with some pizza or something if you feel you need a little bit more one-on-one. Good luck, guys.